Hi, and welcome to another Hopper on microcontrollers video. I'm going to show you how you can very quickly set up a radio link between two microcontrollers on Hopper. I'm using this 433 megahertz radio frequency, which is also shared by LoRa. There's some modules that go twice as fast as this, but for more range. But I prefer the lower frequency one because it works better through buildings, like through walls, like between your house and your garage. I've tested it to about, like 150 meters and it's super reliable. The connection works like a serial port. So you just set the baud rate and you can configure them. There's a pin on the bottom called set where you can send AT instructions to configure it. But by default, I'm just using it straight out of the box with defaults. So let's get started and I'll show you how to do, how to use the UART with Hopper. Let's just do that quickly. So we've got two little microcontrollers. They're both Raspberry Pi Pico Ws. You don't need the W part because we're not going to use Wi-Fi. And what we're going to do is we're going to use these two pins here, UART 0. And just as an aside, UART 0 is not as usable in the old microcontrollers like in an Arduino Uno because it's shared between the connection to the computer. So, and Hopper uses the default serial connection for the debugger. But on the RP2040 microcontrollers, they don't use that UART 0 for this connection to the computer. They've actually got another one, which is the USB connection that's dedicated. It's not the same thing. So we're going to use UART 0 because it's the default when we code in Hopper. So the way we wire up is we do between the two boards, we go TX to RX, RX to TX. So we swap receive and transmit. And the other thing we're going to need between the two boards is a common ground. So first we're going to do this with bits of wire, and then we're going to switch that over to using a radio. So I'm going to do bits of wire, show you how it works in the software, and then switch to radios. I'm just going to wire it up now. Okay, that's all we needed to do was wire up just like that. So you can't really clearly see, but these are crossed over. The top two pins are crossed over. The ground is common. And I've also put in an LED that we can use as an indicator. I've put that onto GP11. Okay, let's go have a look at some software. So this is kind of tricky, actually, because we've got two instances of Hopper open and we've got two serial ports connected. So we've got two serial ports. So how do we do that? Well, if we exit here and we ask about our ports, we can see we've got two serial ports. So normally when I launch into Hopper, it'll just take the current or default one and I can select a default one. But there is also an override. So on the command line, there's a -P. So I've got here -P85. So that means the one on the left in the video is going to be on port 25. And then this one on the right, I've got on port 27. Is that correct? Let's check that there is a port 27. Yes, there is a port 27. So on port 27. Okay, so when the debugger launches, it'll keep them on the correct ports. Now let's have a look at the code quickly. So I'm just setting up my diagnostic LED here. And then this is how you set up the UART. You just set the baud rate. So if I right click on that, it'll show me by default, it's using the default pins for the UART. And if we go back and have a look at the pinout again, these ones in dark purple are the default for UART 0. So I'm just choosing the default pins. And what in this program, which is the TX one, Pico 43TX, this one is Pico 43RX. What I'm doing is I'm getting the time in milliseconds and I'm converting it to a string and I'm just writing it. I'm writing it out to the serial console, which is the USB connection to the debugger. And then I'm also writing the same string with an end of line to the UART. And then I'm doing a short delay so that I can flash the LED for a quarter of a millisecond. And then I'm delaying a little bit to wait for the other device to receive it and then echo it back. So it's going to transmit it back. So if it is available to echo it back, and I'm doing a write here, not a write line. The write line is down at the bottom. If it is available to echo it back, it then loops through and picks up what's available to echo back until it gets to that end of line, which is that end of line, the same end of line it echoed, and then it outputs what it got back. Okay, so I can build this with F7 and then an F5 to run it. It launches it into the debugger. There's an extra little piece of information here in the right-hand side of the green bar, which is, it says it's on COM85. And if we F5 to run, it's sending, and it's actually receiving return values because the program's already there. But I can stop that quickly. So that's because the program was already on the board before I started the video. But let's just have a quick look at this. I'm actually going to just upload it to pause it like that, because it's a bit distracting. So this is what I was planning to do, is we're sending, but we're not receiving. So we've got the left one running and the right one's not running yet. Hopper's too good. It already had the program loaded and just found it and ran it. Okay. So the receiver's a little easier, a little simpler, same sort of setup. Set my baud rate to 9600. It can go much faster along a wire, across just the wire connection, but 9600 is a good speed for when we switch to radios. And then the reception loop, it's like if it's available, collect the characters one by one. When you get to an end of line, that's the end of the message. I'm just doing it one line messages. And then all it's going to do is it's going to send that same message back to the receiver. As the characters come through, it echoes them to its debug console so you can see what it's got. And then when it's done, it's just going to send the word returned plus whatever it captured and send it back. And it's also going to blink its LED to show you for a quarter of a second to show you that it sent something back. So let's just hit F5 to run that. And now we can see the echo between the send and return. So it's only receiving the time here, and it's adding the word returned when it sends it back. And this is the time in seconds, well, in milliseconds. So divide by 1,000 per second since this video started. There you go. So that's a UART working just across 2 wires between 2 microcontrollers. Now I'm going to pause the video. I'm going to swap these 2 wires, the 2 wires we got in there. I'm going to swap them for the radios. And these are the radios, just default settings straight out the box. Let's hook them up. Okay, I'm back and I've wired up the radios. So I no longer need the common ground between the 2 boards. I do need 3.3 volts power, and then I need the ground for the other half of power. And then it's the same pins here at the top that we use for RX and TX. And once again, between the microcontroller and the radio, we swap RX and TX. The modules I got came with these little antennas, which I soldered on. This is default settings. Neither of these programs has been altered at all. It's exactly the same as the one that was sending text across the wire. Now it's going to send it across the air. Let's try. So we'll load this one and run it, and it's starting to send. And then if we go to the receiver and we run the receiver, it's not really a receiver, it's echoing. So there we go. Same thing happening. We're echoing our the text we received. We received the milliseconds in text. We appended over here, and we appended the word returned and send it back. And I found it to be super reliable. I've actually implemented this on another board, an Adafruit board, this one, because I could put a LiPo battery on it and I could walk down the road with it. So I could go and try it in, the garage with the door closed and, rebar and concrete. And I could also just walk down the road with it and see if the light just continued to flash and, how far I need to go before it starts flashing. Anyway, I love these little modules. It's much easier to make it reliable, I believe, than if you use more complex modern protocols. I've had trouble using Wi-Fi because eventually, my Starlink gateway fails, or the device, one of these little microcontrollers with a Wi-Fi module on it, just fails to connect. So I want to make reliable stuff that just runs forever. And this is both a simple protocol and one, thanks to the little microcontrollers on each of these radio boards, where they've gone to some trouble to deal with noise. and try to make it reliable. The internal protocol is pretty good. There you go. I'll put links to the module, and I'll put in the description of the video, and also links to just switch will be the code that was the sample code that was in this video. Thank you for watching.